Welcome to this explainer. I am absolutely thrilled to have you here today. So think about when you first get into your car. You look at the dashboard, right? And it immediately shows you the baseline health of your vehicle, your speed, your fuel level, maybe the engine temperature. Well, that's exactly what standard cloud monitoring does. It gives you the essentials. But what if you're driving a high-performance vehicle and you need to know the exact tire pressure differential on the rear axle to actually win a race? Yeah, that standard dashboard just isn't going to cut it anymore. Today, we are setting the stage to unlock true business-aligned observability by deploying custom metrics in Oracle Cloud Infrastructure, or OCI.
Okay, let's dive into this. Here is our roadmap for today. We're going to look beyond default database monitoring, enter the world of custom OCI metrics, map out 2 different paths to deployment, navigate the prerequisites and setup, and then finally, we'll troubleshoot instance principles. No fluff, just the practical steps.
All right, Section 1, Beyond Default Database Monitoring.
So, OCI Observability and Management provides a highly scalable and frankly incredibly robust foundation right out of the box. It easily captures default metrics like CPU usage, storage, network throughput, the whole shebang. And these are fantastic for monitoring general health. But there is a gap. While default metrics are great for that general health check, custom metrics act more like Formula One telemetrics. We're talking about capturing specific business-critical database aspects that the default tools just miss. Highly specific indicators like your data guard transport and apply lag between primary and standby databases, or granular performance stats like shared pool memory utilization. These are absolutely critical to your actual operations, but you have to build the bridge to see them.
Which brings us to Section 2. Enter custom OCI metrics.
To bridge that visibility gap, the architecture we're exploring today is built on Todd Sharp's foundational GitHub code. Todd wrote this awesome blog post and provided the Java architecture that serves as a literal blueprint for creating user-defined custom metrics and publishing them to a metric namespace in the OCI monitoring service. It is such a fantastic example of developer community collaboration, and a focus today is taking Todd's foundational code and actually deploying it into the OCI cloud environment to complete that observability picture.
Moving right along to Section 3, 2 paths to deployment.
Now, what's really interesting about this slide is how it highlights the incredible flexibility of the OCI SDK and command line interface. You literally have so many deployment options. You could use the Fawn project to push a Java app into Oracle Functions, or you could run a shell script via a cron job that streams logs into OCI's logging service. It's totally up to you. But today, we are looking at 2 primary paths. Option 1 is your local laptop environment running the Java program directly in IntelliJ. Think of this as your sandbox for initial testing. Option 2 is your production-ready cloud deployment, where you build a jar file and schedule it via a cron job right on an OCI compute instance.
All right, Section 4, Navigating Prerequisites and Setup. Listen, for all you IT ops professionals out there, I deeply empathize with the pain of wading through dense, complicated setup requirements. It's the worst. So we've broken this down into a really manageable checklist for Option 1, running locally. First, ensure your user account has the Manage Metrics permission. Second, verify your user belongs to groups with those same permissions, specifically for the compartment you're targeting. Third, create a database schema user account dedicated solely to monitoring. Fourth, allow the database connection from your local laptop environment. And fifth, just update your VCN subnet security list to actually let that local connection through. Boom. Punchy, declarative, and super easy to verify.
Let's move to and see how this builds when we shift our environment over to a compute instance for Option 2. Notice the immediate shift in prerequisites here. Step 1. We now have to create a dynamic group specifically for the compute instance. Step 2. We grant those Manage Metrics permissions to that new dynamic group. We still need our database schema user from Step 3 and the network access rules from Steps 4 and 5. But check out Step 6. This introduces a new element. You now build the application using Gradle, following the IntelliJ Getting Started documentation.
And finally, Section 5, Troubleshooting Instance Principles.
Okay, so even with the most perfect checklists in the world, roadblocks happen. And we've all been there with frustrating IAM permission errors. You schedule your cron job, the code runs, and out of nowhere, bam, an exception. Specifically, an authorization failure when publishing the metrics. Encountering this is incredibly common, and it directly ties back to how the compute instance itself authenticates. The root cause is almost always the compute instance dynamic group permissions.
So, let's clearly define what we're talking about here.
Instance Principals is an IAM service feature that enables your compute instances to actually act as authorized actors or principals to perform actions on service resources. Every single instance gets its own identity. So the crucial point is that it brilliantly uses automatically created and rotated certificates. This completely eliminates the nightmare of manually distributing and rotating credentials to your hosts. It is a massive time saver and solves the authorization roadblock seamlessly, but of course, only if it's configured right.
So, here is your exact fix to clear that hurdle. First, identify the compute instance's dynamic group. Next, update the policies to explicitly enable those manage metrics capabilities. Third, and actually this one is absolutely critical, ensure you apply that policy to the specific compartment where your metrics live. Once you apply those policy updates, verify the logs to ensure that the authorization failure is completely resolved.
Which brings us to the end of our explainer. Before we wrap up, I want to leave you with a provocative question to consider regarding your own environments. Really think about this. What critical database metric is missing from your dashboard today? Think about your observability blind spots. Are you missing a highly specific data guard lag, or maybe some granular memory stats? By leveraging this architecture and the flexible deployment options in OCI, you can finally bridge that gap. I hope this structured look at deploying custom metrics leaves you eager to tackle your own monitoring challenges. Thank you so much for learning with me today, and keep exploring.